Two ways to work. Number one, you could use a quotient rule, or you could rewrite it and use a product chain rule. Well, actually just a chain rule, because you could call this 3 times 4 plus x squared all to the negative first power. Either way, it's totally up to you. I imagine most of you did quotient rule. Low d high, what is the derivative of 3 zeros? Minus high d low, all over low squared. So negative 6x, 8. Is that what everyone got? Okay. What's the rule for a number to a power? Natural log of that number, so natural log of 10, times 10 to the x squared minus 1, right? Times the chain rule, 2x. And what does that give us? D. And last one, implicit. We got to do some work before we actually get to dy dx. We get 2x plus, what do I have to do with the x times y? Product rule left, d right, plus right, d left. Plus 3y squared y prime equals 0. Even if that was not a 0, any constant there would give you a 0. Collect all the y prime terms on one side, and I'm going to go ahead and factor it out if y'all are okay with that. So I've got the x and the 3y squared times y prime. On the other side, I have just the negative 2x and negative y. Is that right? And then divide by x plus 3y squared. It's got to be this one. Now, what's a little different, this answer and my answer? They factored out a negative 1 at the top, pulled out in front of the whole fraction. Fair enough. Okay, what is the formula for the area of a rectangle? Length times width, just because of notation, I'm going to stick with what they have here, but exactly the same thing. Base times height. What is an area of a triangle? And what is the area of a trapezoid? Good. The way I remember this is we're making it into a rectangle. If you average the bases and then multiply it by the height, that's how you get the area of a trapezoid. Average the bases, multiply by the height. So 1/2 base 1 plus base 2 is the average of the bases times the height. We're going to need those formulas today. We talked about exploration 3 yesterday. I think we talked about everything we needed to with units there. So today we're going to start integration. Just touch of the surface on integration today. All about area today. In the first semester, we spent all of our time mainly on derivatives, which was, as you know, the slope of a curve at a point. We found a lot of real-world applications. We spent a whole chapter on real-world applications of the derivative. The second semester of AP Calculus is all about area and integration. And as you discovered yesterday in Exploration 3, area under a curve has real-world meaning. And if you forget what that real-world meaning is, go find the area of a rectangle with units and look at the units on that area and see what it is. The area under a velocity curve we found out yesterday was distance. The area under a volume curve, or under an area curve, we found out was volume. If we did the area under a curve that was the rate of change of water leaking out of a bucket, we would get the amount of water that leaked out of the bucket. So there's some really good information that we can get from area. The definite integral is the area underneath the curve between 2 points. And that's what we're going to be learning about today. There's two important concepts that aren't necessarily something that just comes natural to your brain that we need to talk about. And the first one is that area in this context will have a sign. We can have a positive area and a negative area. You've never had that before. Well, why? Well, if we start talking about velocity, what does a negative velocity mean? You're going backwards. What does that do to your distance? It makes it negative, right? It gives you a negative distance, or in net distance. It takes away distance. So that's why in this context we have to think of area with a sign. If it's going to make sense for the real world application that we have, then we've got to take into account a sign on area. Area is no longer just what's there. What's the size of that square? It's actually it has a real world context. And so because of that, we can have a positive area or a negative area. The integral is the area that the curve makes with the x-axis. So if I went straight down to the x-axis, that is the area, or straight up to the x-axis, that is the integral. If that area is above the x-axis, it has a positive value. If that area is below the x-axis, it has a negative value. And again, the real world context of that is, say we have distance, then we have a negative distance there. For rectangles, if I were using rectangles to find a height, the height of the rectangle would be f of x. In other words, the f of x is the same as y, so it would give you the height of the rectangle. And the base would be the change in x, or delta x, right? So if we're using trapezoids, same thing, the height is delta x, and then the bases are two different f of x values. So we'll look at that more tomorrow. Here is some notation. This is the thing you've seen that kind of scared you at first, probably. And this is the notation for exact area. This squiggly line here is the integral sign. And where it comes from is we are literally, as you saw yesterday, adding up squares. Now, what's a word for adding up things in mathematics? Sum. So why do you think they use this symbol? It looks like an S. We're summing up the area from the x value A to the x value B. These are called our limits of integration, but they tell you where to go from and to. Obviously, summing up area has to have an endpoint, otherwise, most likely you would get infinite area. I'm going to say most likely. For those of you going on to Cal 2, there is a chance you could sum up an infinite area and get a finite answer. It's craziness. But anyway, forget that. So the integral from a to b of f of x, which is the function, the y value, dx. Now you may wonder why they use this notation. Well, aren't we summing up base times height on a bunch of rectangles maybe? We'll talk about that later. But this would be the height, and delta x, or dx, teeny tiny change in x, would be the width. We'll talk more about that notation later. But this means find the area from A to B under the curve f of x. You just have to know that that area could be negative. When you find the value or the area, we say you have evaluated the integral, or found the value of the integral. The function is called the integrand. And the x is the variable you're integrating with respect to. It's the x value. Are you bringing that back?
I'll bring it back.
Okay. So, our first integral problem, it's really geometry. Not really an integral at all. So, I want to find the area, or the definite integral, from -5 to 5. So that's from 1, 2, 4, 5 here. Let me use a different color. From here to here. Okay. Now, this is baby stepping us through. Eventually you'll do that all on your own and break it up as you wish. But the first thing it has me do is find the area from -5 to -3. Why do you think it has me do that first? Because it's a square. It's easy. Well, what is that area? 4. Except, why negative? Below the x-axis. So that area is for this area. Why do you think it goes from -3 to -2? Why do you think it stops there? It's still below the x-axis. It makes a nice shape that we know how to find the area of. It's a triangle. We can do that. We could have been a little more clever and just done a trapezoid to begin with, but that's okay. How do you find the area of a triangle? 1/2 base times height. And what is that area? 1. And it is negative because it's below the x-axis. Then they have us find the area from -2 to -1. I'm going to ask why one more time, but you've probably gotten the gist. Why are they stopping there? To find the area from -2 to -1. Makes a nice triangle. If you kept going, it makes a shape that I don't know how to find the area of. So they're just breaking this up into manageable. Like, this feels like some bad geometry project, doesn't it? Where we're just finding the area of a bunch of little shapes. So that area is also 1. It is positive, though. You will get to a place where if you were truly working this problem, you wouldn't find the area of either one of those triangles. You just cancel it out, because what's going to happen when you add -1 plus 1? It's going to be 0, going to go away. So at some point you just say, there's no area, no accumulated area there. But okay, then we go from -1 to 0. This one you could break up into a triangle and a rectangle, but for something we're going to do in the next couple of days, you will need to be able to find the area of a trapezoid, so I'm going to call this a trapezoid. Has a base or a height of 1, and then it has 2 different bases, one of 2 and one of 1, 2, 3, 4, 5. Does everyone see its trapezoid on its side? So we have 1/2 times 1 times, what did I say, 5 and 2? So 2 plus 5, which is 7. So 7/2. And that is positive. And then from 0 to 3, better not use yellow, might not be able to see that. We'll go back to red. From 0 all the way over to 3 is another trapezoid. The base of that is 3 units. And then we have a height of 5, so we have 1/2 3 times 5 plus 3, which is 8. 8 divided by 2 is 4. 4 times 3 is 12. Still positive. Would we agree with that? One-half base times height. Now, it looks like they gave us this breakdown for some, but can you now see why they picked the breakdown they chose? And so what is it, 3 over 2? And negative 3 over 2 for the green area, the next one. Then it asks me to find the integral from negative 5 to 5. On your homework, it probably won't give you this table. It might on one of them, but at some point it's going to let you go and let you do it without the table. So you'll have to break it up accordingly. Remember to always make your areas with the x-axis. Don't go down here or something weird. Always go straight up or straight down to the x-axis to make your area. So the integral from negative 5 to 5 is, let's see, negative 4, that's negative 1/2, 11.5, is that right? Everyone know how I'm getting that? Just add them up. So that is an integral. Now you can imagine this would be very tedious if the curves got complicated. This was doable because the curves were lines. And we can always find the exact area without using calculus with lines. And that's what our goal for today is to just find area of figures that you know the areas of. The only thing that might be added is a circle. Does everyone know the area of a circle? Pi r squared. So you might have a semicircle or something like that on your homework tonight. But your homework tonight, the focus of it is finding area. The which one?
Like the next point. At 0, 5.
From negative 5 to 5? Is that what you're talking about?
No, I'm talking about like the I don't know.
The maximum on that calculator is something.
What if it was below the x-axis?
So just pretend this part wasn't even here.
Yeah.
Just go from negative 5 to negative 3 or negative 2. That whole piece is below the x-axis. And so your area would just be negative. Is that your question? So it doesn't matter whether it's up here or down here. We're just going to draw the shape with the x-axis. If it happens to be down here, we would make it up to the x-axis instead of down to the x-axis. You'll just find that shape, find the area. Add them up. So for today, no calculus for today. We'll see how this relates to calculus and how amazing it is that this can be done quickly with calculus. But for today, we're just finding area. Yes.